Question 5. Now the key bit to take on board here, we're talking about the number of real roots. So we've got to work out the discriminant. And remember, the discriminant is b squared minus 4ac, where a is the term in front of the x squared, so p minus 1, b is the term in front of the x, so 4, and c is the constant at the end, 6 minus 5. So that's what a, b and c is, and we're going to substitute it into b squared minus 4ac. Well, we've got no real roots, so that means that b squared minus 4ac is going to be less than 0. So substituting these in, we get this, and then working through the algebra, so I've multiplied out this pair of brackets, then I've multiplied each of these terms by minus 4, giving me this. I've gathered up my terms to give me this. I've then chosen to divide through by minus 4. Now remember, when you divide by minus, you change the inequality sign over. So there's no longer less than 0, it's now greater than 0, and that's given me what I was asked to show for part A. Now for part B, I have to solve this inequality. Well, it doesn't factorise, so I'm using the quadratic formula, where A is obviously 1, because we've got one lot of p squared, B is minus 6, and C is 1. So substituting into the quadratic formula and tidying it up, I get solutions of 3 plus or minus 2 root 2. Now, for your final answer, it's always worth doing a sketch. So the shape of this quadratic is a positive x squared, so it's a smiley face when it's a positive parabola. We know it cuts the x-axis at 3 plus or minus 2 root 2, and we want the bits which are greater than 0, so above the x-axis. So we want this stretch of values and this stretch of values. So I want the values where p is less than 3 minus 2 root 2, but also where p is greater than 3 plus 2 root 2. Always give this as two separate answers, as it is two separate stretches of answer.